Hi, this is Real World Assets Multi-Chain Infrastructure, and this is our project. So let's start. Well, this is the component that allows natively deploy cross-chain tokens. In this case, we are running a small test and proceeding step by step. This token has already been deployed. Once deployed, you can see the token's address right here. We have already tested the Chainlink CCIP transfer. Here is the verified transaction, which completed successfully. This manager let us deploy and manage CCIP tokens easily via this wizard. Right now, we are going to review the implementation steps. In this scenario, we want to deploy a new token. We will be working with an Orange Farm token. So let's deploy it. As you can see, the token is now live. Let's confirm. Done. That's correct. Next, we will deploy it to the other network. We will assign the appropriate roll down. Let's continue and set up the tools. Now we will do that on Avalanche. This component also let us bridge tokens across networks. I trigger whenever here because this section is not fully configured yet. Moving on, the final step is to configure the pools. At this point, if we go back here, we won't have any gas estimation issues. What we will do next is approve the tokens. Done. Now we can bridge 10 tokens from Arbitrum Sepolia. It's confirmed. Checking the transaction here. And now that this kind of transaction typically takes around 2 minutes to complete. Let's continue. In this part, we are going to work with requests to call the ELM service we deploy. Consumer will be the contract we have already deployed for this purpose. This is the contract where automation is used, and it will perform the update of the request. Exactly what the UEI we were showing does. Afterwards, it calls send request. In this case, we have already updated the entire configuration. The contract now includes both the subscription and the consumer. And the keeper for automation is already configured. As you can see, it loads the contract and makes the call to send request. For this example, we will make a manual request to verify that it's functioning correctly. And we will check that the keeper is properly configured. It is using the same address, so we should not have any issues. The computation and API call were registered successfully. And we can see in external storage that our token, our real world asset token, is recorded. Here we can verify the value change, and with that we conclude the project's full set of functionalities. Let's continue with the backend, LLM backend. In this moment, we are going to show how the backend works from the terminal where Elisa, our agent Agroeli, is running. And where we have the hash that's generated when we deploy it locally. For this case, we are using Oyama. In this terminal, I have the backend running which make a request to our weather API, and also to Ellie to generate the interpretation of the results. Here I am deploying on port 8000. I am using ngrok, exposing my machine on port 8000 so my teammate can make requests to this URL. And here I have my GPU so that when Elisa is reasoning, we can see how the GPU performs. So let's test our first endpoint. This endpoint will simply forward the request and return the data from the Open Weather API. We will see the weather forecast. For the coordinates I gave it, Bogota, and it returns the forecast up to July 1st. Today is June 27, so we will change that. Next, we will try our second endpoint with the same coordinates valid, once for Bogota, and to see which agent we are using. I will read the hash generated by AgroEli. I will copy and paste my hash, and now I will make the request. While the request runs, we can see the inference happening in OEM locally. We see the call I just made to my backend and watch the GPU usage ramp up locally. Here we have Ellie's response, giving me the general weather pattern and telling me how things look. Let's make another request with the same data. We can observe the request flow, see where our OK response, and also watch the GPU as the local model loads and then see Ellie's response again. That's how the backend works. Thank you so much.